Welcome, everyone. Glad to have you here. And we're going to start our October webinar. And a little bit of information. I'm actually going to try and keep this concise on my end. We do try and keep the webinar quick so that you can get that information, get in, get out. We have a guest speaker today, which we're very happy to have. Dan Hens, who will be talking about the monsoon. So I want to give most of the time to him. If you have questions, though, you can throw those in chat and we can get that information to you at the end of our talk. A little bit for me, what I'm going to talk about is kind of what we've been going through with the webinar and looking at what happened last winter, a little bit on what happened this summer. I'm going to let Dan talk mostly about the summer, but then ending up with what happened with our water year. So we'll go with that. Last winter, obviously, we all remember this as being very cold, very wet. It was an exceptional winter. We had at the end of December is when it really started coming in. But you may remember last October, we had a lot of activity. I was at the state fair. I was taking pictures of the cumulus clouds. It was an amazing October. November was the 15th coldest November on record. So it was very, very cold. But again, at the end of December, we started getting those atmospheric rivers into California. Arizona, we actually can experience about 30% of our winter water supply being impacted by atmospheric rivers if they're coming in at the correct location. And when we're looking at what happened with our winter, looking at October through March, I kind of separate out April. So we're looking at October through March, 23rd coldest, 22nd wettest, really, really helpful for our water supply. We were great to see all of that. Precipitation, because it was so cold, in the form of snow. So that was a great thing as well. And when we look at that snow, we evaluate how much we have based on snow water equivalent in our various different basins. So you may hear about things called SWE, and that's what those images are, that kind of looking up and down with all those different colors. Looking at snow water equivalent in the lower Colorado Basin, that's kind of all of Arizona, looking at snow water equivalent in the Verde Basin. What you're seeing there is that it was a really high, exceptional, above average winter for the snow water equivalent, which was great. If you look at the Verde Basin, you can see that the peak snow before it started melting, it was delayed. So snowmelt being delayed shows how cold it was, which means that's a great thing for our water supply. So keeping that in the form of snow as long as possible means that that snow will melt slowly and move into our aquifers. That's a great thing for our water supply. So then we're looking here at April. So I separated April out. April was an exceptional April. It was very dry. It wasn't hugely warm, but it was exceptionally dry. And you can see that a lot of our counties in the central Arizona area and the southern tier, very dry, no measurable precipitation, tying as the driest April. This is also kind of the starting point for what happened at Phoenix Sky Harbor. So March 22nd was the last precipitation measured. So that means 0.01 inches of precipitation or higher. March 22nd was the last measurable precipitation at Phoenix Sky Harbor. Then we went April, May, June, July with no measurable precipitation at Phoenix Sky Harbor, which has never happened before. So that set another record right in through there. We set a lot of records this summer. I'm not going to talk about all of those records here, just recognizing that it was very hot, very dry. June, we remember, was cold. So that's the starting point for what we need to have happen for our monsoon season to get that monsoon ridge setting up. And because June was the 18th coldest June on record, that delayed what happened with our monsoon. And then, of course, we went into July. It's hard to talk about, hard to remember, but it was the hottest July for the state. And in fact, it was the hottest month for the state on record. And because we didn't have our monsoon getting set up correctly, we had the second driest July for the state. And then looking at the monsoon again, going to let Dan talk about most of this. So really grateful for that. I do want to say that there were two weather stations in Arizona that had their driest monsoon on record. So June 15th through September 30th, looking at the rankings of that, of course, we know that Phoenix Sky Harbor had 0.15 inches, which was their driest monsoon for that weather station. Wilcox also had that same experience. But you look here in the Southeast, a lot of those weather stations experienced in their, I guess you can call it the top 10 driest monsoon on record. If we're looking at the statewide numbers, it was the 15th driest June through September on record. So really dry. You can see that Cochise County and Santa Cruz also had their driest June through September on record. If you remember what happened last year, Cochise County had their wettest June through September on record. So quite a change right in through there. Now, looking at the water year, so we manage our water supply, not just here in Arizona, but in the United States. Water is managed based on a water year. So that runs October 1st through September 30th. And so that's how we kind of keep track of what's going on. It makes sense of whether we're seeing any trends, those kinds of things. This was Arizona's 30th water year in drought. So we look at the start of Arizona's drought as 1994. So we are now in 30 completed years of being in a long-term drought. With Arizona, we look at drought not just as what's happening through a season, but drought in Arizona is more a series of dry years. And so that's absolutely what we've been experiencing. This last water year, fortunately, was slightly above average, thankfully, for that really wet winter. And here's what we are looking at with the water year precipitation. October through March, we looked at already, really, really wet. April to July, the second driest on record. So it really was that April to July that was really low precipitation. Everything else was either average or above average, and that allowed our water year to be slightly above average for our precipitation. If we look at our temperature, we know that we were dealing with really cold conditions October through June, the 33rd coldest on record. But then once we started hitting into July through September, very, very warm conditions, the second warmest for the state. Looking at our drought, short-term drought is starting to degrade. I actually threw water year 2022 in so we can kind of compare what we've been dealing with this water year. Not so bad when we compare it to 2022, but unfortunately, we're starting to see that red show up on our short-term drought maps. And that means we're moving into extreme. And once we get that really angry red, that exceptional short-term drought. Looking at our long-term drought, it still persists. So looking at the water year, that's what you're seeing right through here. So October through September, you can see that last October, we were recovering from a really wet monsoon last year, and then we started getting that really wet winter that really helped alleviate some of that long-term drought. But then starting July, it really just came back as a forefront, and you can see that we're starting to get more of that exceptional long-term drought. What we're expecting for November, this is kind of climatologically normal to have a dry November, expecting it to be a little bit warmer so we can have that coming in. But we are looking for El Nino in the winter. Statistically, El Nino, it brings Arizona a wetter winter. So we're hoping that we're going to see that again. If you look at how many El Ninos we've had in our drought period, we've had 9 El Nino winters. 7 of those have been above average. If we pop back before our drought and you go to January 1993, that was the wettest January on record for the state. That wasn't even an El Nino event. So looking at these kinds of situations, we'll wait until we see it. It's more of a statistical relationship, but we're very hopeful that we're going to have more precipitation. And I invite everyone to join us next month, November 16th. You may remember Paul Iniges from the National Weather Service here in Phoenix. He's actually working for the Center for Western Weather and Water Extremes, and he's going to be our guest speaker next month talking about El Nino. So I'm going to stop sharing now and introduce our guest speaker, Dan, Dan Hens, Flood Control District, Maricopa County Flood Branch Manager. It's a great title, Dan. We're so grateful to have you. Dan's one of our own. He graduated here in Arizona at U of A and completed his master's work at the University of Wisconsin. So we're grateful to have you, and I'll let you go ahead and get started whenever you're ready. Thank you.
All right, thanks for that. Can everybody see the title screen there? Did I do that right?
Looks good.
Okay, great. Well, thanks again. My name is Daniel Hens. I am the Flood Warning Branch Manager over at the Flood Control District of Maricopa County. Again, for those of you that don't know me, I saw a lot of familiar faces in here, which is great. But yeah, I've been with the district now for 12, almost 13 years. I'm a meteorologist by trade. Picked up quite a bit of hydrology, and then again, now stepping in as the Flood Warning Program Manager. It's been a wonderful ride in Arizona here, and we've had a nice little historical context where we've been able to provide some of these monsoon recaps for the last decade or so. I really enjoy doing them. I just want to thank you guys for having me here. And to those of you that have already seen some version of this presentation, I know poor Aaron and Juliana, this is probably their third time. I apologize, but hopefully I can give some new nuggets in there. So let's get started here. So kind of piggybacking on what Aaron talked about before we even get in the monsoon, taking a trip back this past winter. It was cold and it was really wet, not just here in Arizona, but across most of the Western US. I did want to show this. This was part of our monsoon outlook presentation that we gave back in June. The image on the right really is what I kind of wanted to show this. Those satellite infrared imagery here, the green colors that you're seeing that I've kind of highlighted there out in red is just showing winter snowpack. And this was as of May. And you can't really see it too well here, but even across Arizona, up along the Magellan Rim, San Francisco Peaks, White Mountains, those areas all still had quite a bit of snow well into May. So, and as Aaron, let's see here. Ooh, did that not click forward? Let's see here. And it's frozen on my screen.
All right.
Oh, there we go. Okay, so we'll get through this. Yeah. So again, in terms of for the monsoon outlook, with as Aaron had mentioned, when you have a really, really, really wet and cold winter, and that continues on into spring, as well as when you start getting deterministic model guidance, kind of showing, you know, this slower evolution of the monsoon ridge moving north out of Mexico and into the desert Southwest, that kind of tends to give us a good idea that we may be looking at a drier potential monsoon, a less active monsoon. And usually if you've been in Arizona here, Mother Nature, once she takes one extreme, for example, being colder and wet, we usually tend to get our butts kicked in the opposite direction. And again, so modeling wise, looking at it above normal temperatures for the summer. As from our actual outlook that we give back in June, again, above normal temperatures, we're expecting below normal rainfall, a later onset to the monsoon, or even a false start. And again, more erratic behavior with the monsoon ridge. So unfortunately, that forecast verified, and you know, we never like to be right, especially when we're calling for hot and dry. So, but in terms of June, again, piggybacking off of what was already stated by Aaron there, just this was common. If you look on the left there from CPC, the temperature outlook. So this was from mid-June, showing the next 8 to 14 days with well below normal temperatures. Overall, again, in the state, departure from normal anywhere from 1, 2, 3, 4 degrees for June. It was very, very cool. And again, that cool June really suppresses the northward advancement of the monsoon ridge, which really gets everything going. So kind of that forecast of, you know, the drier part, that was definitely coming to fruition. And again, what I just mentioned before, usually if we're quite cool in June, usually it switches on a dime and we get hot. And sure enough, that's what happened. I just wanted to show this as well. This is just kind of this is from late June, June 27th. So we're already in the official monsoon. We're in this southwesterly flow regime where the ridge is actually over central Texas. They're the ones that are baking in really hot. Any moisture getting pulled out of Mexico is actually up and across New Mexico. Meanwhile, Arizona is under the influence of that trough, drier, cooler than normal. This is kind of what it looked like. Sometimes if that trough's a little further west, like in 2022 or 2021, we actually get early influxes of moisture and it can be wetter than normal, but that was not the case. So If you're a purist, I would say, and look at the onset of the monsoon, back how we used to do it before our standard July 15th, excuse me, June 15th to September 30th, we actually would keep track of the dew point, and it would be 3 consecutive days of 55 degrees at Phoenix Sky Harbor, or down in Tucson, it would be 3 consecutive days of 54. If you look at the actual data from this summer, onset would have been July 11th here in Phoenix, and just a few days earlier, July 9th down in Tucson. So a later onset than what we typically see, and then quite a bit of fluctuation in terms of moisture. So in terms of what happens with the heat, so you're looking at geopotential height here, and we're doing this at 500 millibars. So that's roughly halfway up in the atmosphere. And with geopotential height, the yellows, oranges, reds are higher heights. Those can usually be associated with higher temperatures, higher pressure. And then the blues and purples are lower heights associated with lower pressure and usually colder temperatures. And the image on the left is you're looking at the climatological mean 91 to 2020. And this is the mean ridge placement for July and August, or the heart of the monsoon. What we can see there with the yellow H, the center of the monsoon ridge kind of focused across New Mexico, and generally southerly flow streaming north into Arizona, again, getting the moisture, eventually getting thunderstorms, rainfall, all the good stuff. Now, the image on the right here is the July through August mean for this past summer. And what you'll notice right off the bat is the higher heights. So the strength of the ridge significantly stronger, warmer temperatures, what we've already mentioned there, what we saw. I'm going to go over some of these heat records. What I'll also point out with that orange arrow is the general clockwise flow around the ridge. Instead of being southerly or southeasterly, there's actually more south to southwesterly. And especially for south central Arizona, the Phoenix area, southwesterly flow is not what we want to see, because it's an all or nothing proposition where we get rain and storms or nothing. It's the same for central and northern Arizona. Southern Arizona, they were still more in a south-southeasterly flow, and they did a little bit better. But I also wanted to show, so this is last year's July through August. So we can see the ridge, not quite as strong, but definitely shifted much further north along the Colorado-New Mexico border, as well as you're also seeing this nice steady stream of south-southeasterly flow all the way up into central Arizona. Again, we had a really wet 2022. So it's kind of more where we want to see the ridge place in general. So with that, the historic July and August heat, on the left there, you're looking at percentile July and August, so mean temperature. And unfortunately, most of Maricopa County, Pinal County, central Arizona, their record warmest or much above normal. Again, actually, most of the state much above normal. In terms of departures from mean temperatures on the right there, you can see mean temperature departures anywhere from 3, 4, 5, 6 degrees, especially across Maricopa County, and then again further in southeastern Arizona. It was very, very, very hot. And there's a just endless sea of records that we experienced this summer. I'll go through some of these, and there's even many more than this. But again, we had 21 daily high temperature records broken or matched. We had 25 daily warm low temperature records, so overnight lows that are staying very warm. Total days of over 110, 54, which again, we beat 2020's record. And I think on average, we see something in the order of in the mid 20s, like 25, 26, 27 days around 110. So this is more than double. Total days over 115 with 17. Total overnight lows that stayed at 90 or above, 33. We had that 31-day streak of 110 degree consecutive highs. And that streak came to an end on July 31st. So we had a pretty active monsoon evening here. And then right back on the start of August there, it just kicked right back in. So, you know, this easily could have gone close to 40 days. We also had, again, a 16-day streak of overnight lows over 90. As Aaron had mentioned, the hottest, so July, the mean monthly temperature of 102.7 was the hottest on record, not just for the state of Arizona, but for any major city in the U.S. We also set a mean daily average temperature of 97. And I think what I wanted to point out here was just the all-time record warm low temperature in July there at 97. So just so many records. We're still even staying over 110 degrees. So we're continuing to add to this. So let's step away from the heat now, and let's just kind of do a rainfall summary and convective activity. I'm not going to focus on any particular day. I'm going to focus mainly just on South Central Arizona here. Let's start off with the lightning tracker. This is something that I really love to follow. I know the folks over at the NWS, they show these quite a bit. They're great to see. you can see here in terms of, so you have years on the y-axis going from 1990 all the way to 2023, and then we have lightning strikes on the y-axis, and we have Arizona as a whole on the top left, Phoenix on the top right, and we have Flagstaff and Tucson. And overall, what you're seeing, that dashed blue line is to average, just a below average in terms of lightning strike, so maybe less convective activity. Again, Flagstaff didn't do so bad, and Tucson was a little better. But if you look at the state as a whole, as well as Phoenix, you can see definitely a dearth for the lightning activity compared to normal or even other R21 or 22. So Sky Harbor, in terms of rainfall, as Aaron already mentioned, 0.15 inches went for the driest monsoon on record. And if we want to look at this from a precip mass curve, and that's what you're looking at here. So the x-axis starts June 15th, and then it runs all the way to September 30th. And then we have rainfall as the y-axis. And what you're seeing plotted there in between the white and brown is where you'd be at a daily average, making your way up and through. The more brown you see, the drier. If this was above normal or wetter conditions, you would see green. But what we ultimately have there is 5 convective days where we got measurable precip at Phoenix Sky Harbor, all of them coming in August. And then again, right into the start of September. And then that event that we had on September 12th and 13th, but really not a whole lot of any activity. And of course, across the bottom there, you can see the temperature records, just all those little red dots there. It was hot and dry. So if we want to step back now and look at Maricopa County as a whole, and we can kind of start looking at the rainfall amounts here. And again, these are using the alert system for the flood control district. So we have 360 rain gauges spread all around the county and surrounding counties. And that's what we're using to create these maps here. But pretty much anything that you're seeing there in that gray is a ½ inch or less of rainfall. So most of central Phoenix and south central Phoenix area, very dry, less than a ½ inch of rain. And then you start getting into those blues, a ½ inch to an inch, and then greens, 1 to maybe 2 inches, and then over 2 inches into the yellows. Really not a whole lot of that. So another way to look at this would be the rainfall as percent of normal. So any of the areas that you see with the whites, that's right around normal. Greens would be above normal. So we have a few spots, one up here along the I-17 corridor, New River, and then another gauge focus spot there out along I-10, right along the border, Maricopa County border there. But otherwise, you're looking at well below normal in terms of rainfall, down into the 10% of normal, 20, 30% of normal. And of course, there's that really dark purple right around Phoenix metro area and up into the Sky Harbor area. Very, very dry. So here's another way to look at that. And what you're looking at here is the last 15 years or so. And again, it's a precip mass curve. So the x-axis is you're moving along in terms of days starting from June 15th to September 30th. And then accumulated rainfall is in the y-axis. And I'm going to take out some of these years here to make this a little easier. And what we're seeing is the green and red. So green being 2023 for the monsoon, 2020, our driest there would be in red. What we see typically would be for the mean there would be that dashed black. And then we have some wetter, more recent years, including 2022, 2021, and then of course, 2014. So in terms of the rainfall here, this is average rainfall across all of our gauges. Okay, so we're not looking at one gauge. This is giving you kind of a regional perspective.
We'll just wait a second here and hope the tech comes back in. And I hope everyone's getting some information. It's good to see a lot of familiar names. Glad to have that. So we'll see if we can get that back in. Appreciate your, unfortunately, we are kind of used to the tech issues now, aren't we all? We've had a lot of experience with kind of what we deal with. So Dan may come out and come back in. Yep, I think that's what's going to happen here. So while we're waiting for Dan to come back in, let me know if you have any questions. What I think would be really great is next year to kind of expand this to an hour. Usually my webinars are half an hour so we can get in and get out. But if you could go to chat and let me know if you'd like to hear this a little bit more detail, so you can hear a little bit more about the water year, how that all operates. So what I am is the co-chair of the Drought Monitoring Technical Committee for Arizona. And we meet every 3 months talking about what's happening with drought in Arizona. And then every 6 months, we meet as a group to advise the director of the Arizona Department of Water Resources, who then advises the governor about our drought status. So we're just about to do that in November. Everyone's invited to that. It's open to the public, and you can hear what we talk about when we're reporting our drought conditions or lack thereof with our state. And waiting a little bit for what we have. Hopefully Dan can get everything going that he wants to do. Tech is just amazing. So yeah, if you could throw in chat if you'd like to hear this for a little bit longer, for this particular thing, because we're doing the monsoon and the water year wrap up. It's a lot of information that goes on, and believe me, it's a lot of reporting that we do. So we spend a lot of time doing a lot of reports that go out to the public, that go out to the state, various different county levels, and so on. So I am not, see, thank you for your feedback. I appreciate that, Stacy. Thank you very much. All right, do we think we'll give it, if you can give me a heads up, if you want to hang out for another few minutes to see if we can get Dan back in, let me know. Yeah, I know. Good to see you, Mike. Nice to have you. Good to have you here. All right. So very, very good. If anyone has any questions about the water year, I'm happy to talk a little bit more depth. If you were popping in before I started recording, you know that there's a lot of things that could be said about these ideas. So I'm happy to answer questions. If you have any questions right now, I'll go ahead and let me put the chat up. And thank you for all your feedback. I appreciate that. Thank you, thank you, thank you. So, oh yeah. Hi, Kurt. Good to see you. Wondering about the impact of the rapid onset El Nino on our summer monsoon. So it was obviously very, very hot. I mean, when you're looking at El Nino, what that is it's an increase of sea surface temperatures in the equatorial Pacific. I mean, it's a very specific location that we're monitoring, looking at what's happening with the temperatures at that area of the ocean. And so obviously the Pacific Basin is the largest that we have. And when you start heating up tremendously, everything gets really hot. So that really did play a role in increasing our temperatures that we experienced here in July. And unfortunately, that ridge that we need for our monsoon just did not set up. It expanded. It was over the Southwest. And that did impact us with what we experienced as well. Thanks for that question. I appreciate that. Chandra, good to see you. Yeah, Kurt's correct. It will change. This is the thing when we're dealing with El Nino and we're dealing with La Nina, what that does is it has impacts to our global winds. So when we talk about the trade winds or the westerly winds, we can impact what's happening when we're changing sea surface temperatures. And that does affect where the storm tracks go, and it affects where we expect to have storms. And that's why with an El Nino event, what that tends to do is it tends to bring the storm tracks down here in the southern tier. A La Nina event tends to keep the storm tracks kind of more north. We had 3 La Nina events in a row. We had 2 La Nina winters that were really dry. And then this past year was actually a La Nina winter, and we saw what that did for us. So I think I'm going to go ahead and stop recording and to thank everyone for attending. And we'll get Dan's slides up so everybody can see. But thank you very much. I'm going to stop recording now.